Now looking at this question, you're told that if a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds. Now the distance it covers in the last 1 second of its motion is, and we're given this option. Now here is the diagram, okay, which means this is the velocity and here is the time, okay. All right, now this is a velocity time graph because it is a graph of velocity with respect to time. Now it implies that at 90 meters per second, that's traveled in 9 seconds. Then in 10 seconds, now the speed or the velocity is 100 meters per second. Alright, now to this end, the question now is the distance it covered in the last 1 second. So in the last 1 second is between 10 and 9. So the 10th seconds minus the 9th seconds. Alright, now take note, since it starts from rest, our u is 0. Alright, now making use of this equation, okay, so to that end, the whole of ut is 0 because our initial velocity is 0 because the car starts from rest. So at the end of the day, our equation becomes at squared all over what? 2. Now to this end, our a, which is acceleration, is given as 10 meters per second square. Okay, now since we are asked to find the distance in the last 1 second, now it means is the distance. So here we have that the distance will now become a then times t square for the 10th second minus t square for the 9th second all over 2. Okay, right. So to that end, we have that this is 10 then into, now for the 10 second here you have what? 10 raised to the power of 2. Okay, let me just do it like this. Since this is, you have 10 raised to the power of 2, which is what? 100, minus 9 raised to the power of 2, which is what? 81. And at the end of the day, we end up having this will be 19 then all over 2. Now 2 here 1, 2 here 2, so we end up 5. So we end up having it should be 95 meters. Alright, and C is the right answer for the question. Alright, thank you.